First question.
Yeah.
I always get semantic caching and semantic search confused. Can you shed some light?
Good question. So semantic caching actually requires semantic search. And the reason for that is unlike regular caching where we do exact match on, let's say we get user input. And we will typically, let's say, run a hash function, generate a unique ID, and then we would query a local cache, most likely Valkey, hit some third-party API, regenerate the data, and store it. But the match will be exact. Now with semantic caching, we're doing semantic search first. And the reason that's important is because with the regular caching, we usually have a very precise input.
Mm-hmm.
So here's an example. Let's say we have a website and the user types a zip code and we give them weather for that zip. So we're in Seattle. If somebody types 98101, we can hit the National Weather Service, specify that zip code, get back the response, and cache it for, let's say, an hour, because that's a reasonable amount of time. Okay. Well, with a semantic or with a agentic application, we don't have such a precise input. You may type, what is the weather in Seattle right now? I may say, tell me today's weather in Seattle. Semantically, very, very similar. But if we were to run a hash function, we would not find the corresponding key. Inject an extra step of doing first, we vectorize that in. Now, doing that requires you to call an LLM. But that is a very cheap call to do vectorization, in contrast to running inference, which is much more expensive. So we call an LLM, we take that input, weather in Seattle, we get back a vector, basically a large amount of numbers, and then we do a vector similarity search. So if we find a match in our database, we use the corresponding cache. If we don't find a match, we then know that it hasn't been yet cached. So then we query third-party API, whatever, National Weather Service. We get back the data, and we store both things. We store the vector and the cached content. And we decide how long. So let's say for an hour. So any user that then comes to our website or uses some agent, queries us and asks us weather in Seattle, today's weather in Seattle, we'll be able to do a similarity search. If it meets our similarity threshold, we will get back a response from the VSS query, and then we will use the corresponding cached content. Now, there's a very important concept of similarity threshold. So just like with regular caching, we have a kind of like one dimension of TTL. And we understand that the longer we wait, the longer we keep the data, the less relevant it becomes.
Yep.
So if we were to cache our weather for, let's say, a month, it would be obviously useless. But there could be other use cases where caching something for a month is reasonable. With vector similarity search and semantic caching, you have a second dimension of similarity. So for our similarity with geographic proximity, we could say, well, we don't have weather in Seattle, but we have weather in Bellevue. Close enough.
Yep.
If we don't have weather in Bellevue, well, maybe it's Tacoma. A little bit less accurate. And if we don't have Tacoma, maybe it's San Francisco. Obviously, weather in San Francisco, whether right now or a month from now, will be very unlikely to be the same as the weather in Seattle. So those are kind of like the basic concepts.
In this case, if I have a similar enough answer that's cached, you're saying asking what is the weather in Seattle and tell me about the weather in Seattle will produce that cache hit.
Yes.
And that saves an extra trip to the LLM.
It saves running inference against LLM.
Got it.
Which is where the costs are and where I think the scalability bottlenecks can be. How many GPUs are there in the world, right?
Yep, we're at a capacity constraint for sure.
Yeah, and I think you can think of it as like we're trading expensive GPU hardware for commodity hardware that we store the cache.
So then I'm curious, as an engineer, let's dive deeper into the technical details. Valkey is built to be a highly scalable distributed cache. What are some of the technical constraints you had to consider building semantic caching in Valkey? Well,
to support semantic cache, you need not just Valkey, but you also need Valkey Search module. So Valkey Search is what allows you to do the vector similarity searches against the data in Valkey. So you would typically use either hash maps or JSON data structures. You would then create an index of hierarchical, navigable small world, HNSW type. And you can specify it to be only on certain documents with a certain prefix. And you can also specify it to be on certain fields with all the documents, either JSON or hash maps. And when you insert data into those fields, the Valkey search will automatically index those. So then you can run the FT search queries and specify the similarity threshold that I mentioned, and you would get back the match or not.
So HNSW.
HNSW, yes. Easy to pronounce.
So tell me a little more about HNSW. And Valkey is a memory store.
Yes.
It stores most things in memory. How do I think about that as a user in terms of resource?
So data is going to be stored in memory, and HNSW algorithm can consume a lot of memory because each of those vectors that I mentioned earlier, depending on the number of dimensions, will take, let's say, 4 bytes per dimension. So again, if each dimension is 32 float, that means that each dimension is 4 bytes.
Got it.
So if you're storing, let's say, 4,000 dimensions, because that's what your LLM returns, which is, by the way, appropriate number for reasonably accurate queries. Like you can go down to as little as 16 dimensions with OpenAI. You can just specify it as one of the parameters, but you're not going to get very good responses with so few dimensions. So, but 4,000 dimensions, 4 bytes per dimensions, we're talking about 16 kilobytes of data just to store the vector. On top of that, you'll be indexing that vector in HNSW index, and indexes take more space. And on top of that, you also be storing the actual cached content. So you have to be very conscious of your memory usage.
And it's possible that the ratios between those indexes, the vectors, and my cache content kind of can become a little imbalanced, right, if I'm not careful.
Well, you want to specify appropriate TTL, and you probably want to get rid of your vector and your cached content. Because if you need to rerun the vectorization, you can just call LLM again. But storing that 16 kilobytes of data without the corresponding cached content, which means you'll have to make another request to LLM to not to just run inference, then store it, then probably doesn't make sense. So I would optimize on just appropriate TTL policy.
Got it.
It's the same with regular caching, right? Like if you don't have LLMs, if you're just using regular Valkey caching, well, how often are you going to need the data? Let's say you have a database and it's got large disk is much cheaper, and then you're starting caching a lot of things and you're now storing it in memory. How likely are you going to need it in the near future?
Yeah, it sounds like you need to sort of, depending on the use case, apply the same kind of logic you apply to regular caching.
Yeah, it's all about trade-offs. There are no solutions, only trade-offs.
Makes sense. So then let's talk about applications. What are some of the common use cases? How do other people integrate semantic caching into their workflows?
Well, we're trying to figure that out. And I'll tell you from personal experience, I love using AI. We're using GPT-5.5 models. They're great. They're helping me be more productive. But I don't know how much it's costing.
A lot, I bet.
Right. It is, right? Somebody's running those GPUs somewhere. And I think at some point in the very near future, and I think it's already happening, you're starting to see articles like Uber blew through their annual AI budget in a matter of months. So I think at some point...
I think they're out of their 2026 budget already for tokens.
I'd be very curious to walk down the street and talk to them about it, but I don't think they'll give us the details. But I think of it as just like how cloud became popular 15 years ago. And the first pitch was like, hey, it'll save you money. You don't need to spend $1 million building a data center. Well, about a year later, you started seeing articles, companies saying instead of spending $1 million up front, we're spending $100,000 every month. So I think the same thing will happen with AI, that people will become just like FinOps became a necessary tool for managing cloud costs. There'll be something similar for AI expenses. And again, you don't have to send every request to an LLM, just like we understand that we don't need to run a SQL query against the database. We're making a trade-off. Maybe it's a little bit stale, maybe it's 5 minutes delayed, but we get it faster and we're decreasing the load on our primary database, keeping our DBA happy, but also keeping our CFO happy and scaling our applications. So the same thing with LLMs. Like we will need to use AI, no question about it, but how can we use it in a cost-effective manner? And perhaps there'll be different pricing tiers. That basically, if you're willing to pay extra, then the query goes to LLM. But if you want it faster and cheaper, then you get it from the cache. And I'm sure various AI companies are already doing that. But this is something that you can implement if you're building agentic ecosystem. You, instead of one agent talking to another agent, talking to a third agent, each of agents will make its own LLM call or multiple LLM calls. If we can reasonably accurately cache the data at the first agent level, we've just a bunch of cascading LLM calls, similar to how we do in microservice architecture, right? If microservice A has to call microservice B and then wait for microservice C, and if microservice A can just cache the data with high degree of accuracy, right? That's that's the most important thing.
Yeah.
We've all seen situations where wrong data was cached.
Yep.
And then users would complain saying, what is this? That's not accurate. This doesn't make any sense.
What about using databases directly? You mentioned databases. I have heard of storing vectors inside pgvector for Postgres.
There's pgvector, there's Pinecone.
Yep.
Yes, absolutely. And there are advantages to that, especially if you're very concerned about memory usage. As I mentioned, each vector, 60 kilobytes of data with 4,000 dimensions. There are definitely disadvantages to that because you now have to have two technologies, right? You have to have one store where you're storing the vectors and then another technology where you're just storing the cache. With Valkey, you can store both and the cached content, and you can then expire both of those at a certain intervals. Because, like, how long do you need to actually store vectors? It depends on the data, right? Like, if you actually have your data that you're storing in your database already, then sure, it makes sense to just create another column on that table and store the vector representation of whatever the relevant fields are. But if you are responding to user prompts where you probably don't want to store forever, weather
there's
in
TTL
Seattle,
naturally.
Exactly. Yeah. So the advantages in this natural TTL kind of helps.
So again, it depends on the use case.
It depends. Welcome to software industry. Right?
Yeah.
It's like weather. Well, it depends.
Yeah. What do you want to work on for semantic caching? I'm sure there's lots on your mind, but what are some of the top things?
It would be very interesting to build like some kind of a simplified solution that just basically allows you to use semantic caching with the same simplicity as regular caching. Just like with the regular caching, it's just a get set. That's it.
To simplify it down so that the users don't actually have to understand what's going on.
Users have to just like, maybe like higher level API abstraction.
Well, I think a lot of that depends on user feedback. And we're always looking for more community participants and contributors to Valkey. We're always welcoming new members to our Valkey Slack community. I know you'll be speaking more on semantic caching on Valkey at our Unlocked conference as well in May. And there will be more opportunities to talk about it in the future as well. We're really looking forward to it. If you want to learn more, please join us in the Valkey community. Thank you again, Dmitry. It was really nice to chat about this, and I learned a lot.